Okay, I just wanted to try to follow up on our results. Okay, so what I've done is I've made a class set which will probably be different to yours, but nonetheless I'll discuss my data and I want to try and put it into perspective. Okay, also I've had a couple of inquiries about the template um, criterion sheet, so I will try to address those in this short video. Okay, so basically where we are is that this is the numeracy 35 question results. So I have identified that there's a mean or average of 15.9 correct answers out of the 35 for the class that I have generated. Okay. The other thing is that we did standard deviation the other day. I showed you how to do that. Basically, I have also for my class set standard deviation of just over 4 and 73 hundredths. Okay, well, it's actually, when you round it, it's probably should be 4 and 74 hundredths. But nonetheless, they are the two values. Now, I want to try and explain a little bit about how we can interpret that, but I'll have to go back and explain first about how the data can be distributed to make sense of it, and how we can make sense of it. Okay, so basically, there's a lot of different ways that data can be distributed. When we present our data in a histogram, which will be one or two videos downstream of this, we will find that the data could look like any of these depending on your class set. Okay. Now, as a general rule, most data sets have a normal distribution, which is also referred to as a bell curve. Okay, you can see that there's a lot more commonly scores towards the middle. Okay, and it tapers off both ways. Okay. Now, why it's got a bell curve is because basically statisticians accept that it seems to be shaped like a bell. It's not very technical. Now, basically, I want to try and go through the mean and standard deviation. So, really, what the mean is about, it's called a measure of central tendency. What that really means is it's a value that attempts to describe the data set by finding the central position within it. So, really, our mean is what we have identified as our central data set. Now, in a normal distribution, the mean, mode, and median, which are all different measures of central tendency, are basically in the same position. So in some other ones with different arrangement, they may be different positions. Okay. So basically, I want to try and explain now about standard deviation. So standard deviation is all about trying to define the variability. So deviation means how much that it is deviating. So we want to find out about the variability and the variability, how much it is varying from that central value that we've identified in the mean. So this is some simple rules which would be typical of a normal distribution. Okay, now ours might not be that close to a normal distribution, but still these may be useful when interpreting your data. Okay, so 68% of values fall within the one standard deviation of the mean value. Okay, I'll explain a little bit more about this. Okay, 95% occur within two standard deviations of the mean. Okay, so that means 34% are lower here and 34% are higher than the mean by up to one standard deviation. 95% lower here, two standard deviations lower, 95%. Okay, so that's half of 95%. And the other half is on this side, which is two standard deviations higher. Okay, so 34%, 34%, okay, 47.5%, 47.5%. So basically, at least you understand when you see values what they mean, so you've got a good idea. Okay, now what does it mean to us? This is our numeracy set. I have worked out that for you just here to show you. So 15.9 is the mean. If we take away one standard deviation, it is that. Okay, so just over 11. If we add one standard deviation to that, it is this value. So just from the expectation would be in a normal distribution that 68% of values would fall between 11 or just over 11 and just over 20 and a half. Okay, so basically we can interpret things from those values. So the larger the standard deviation, the more variability that there is, so the more spread out it is. Okay, 95% of values will be expected to fall between 2 standard deviations of the mean either side. Okay, so I've basically multiplied that by 2, taken that away from the mean, and I come up with just below 6.5. When I multiply that by 2 and then add it to the mean, I come up with 25. So 95% of values should really be between about 6.5 and just over 25. Okay, and when we look through the data, I think that you'll find that there are no values lower than 6. Or I don't even think there is 6. And I think there's one value that's 27, which is higher. So that seems to be pretty good. Okay. When we do a histogram in a couple of videos, we'll be able to really have a look and see what we find supports it. But as a general rule, I expect it to be at least approximating what is going on. Okay. Now, at this point, I just want to try and raise one issue. A couple of people have been inquiring about the template rubric for the assessment, which is quite a similar task to this. I want to just try and mention how that, what I've talked about, fits in with it. Okay, the inquiry's really been about the term scale of measurement. Okay, now the scale of measurement in maths, it actually has a couple of different meanings, but what I would like to do is really just simplify it and say to you that in the context of where it occurs, it's in the distinction level, and it's in the top left-hand corner, what areas of numeracy are examined. Describe each area of numeracy tested correctly. Okay, that would be something you'd be expected to do. And describe the class average performance and the variation in relation to the scale of measurement. Okay, so basically you would have to talk about how much that it varies in relation to what scale that we would have, so the range that is possible and the range that we've observed. So basically this would be quite valuable to talk about because it's going to be good for talking about the variation. The next times that's cited or something similar to that is the level of on the measurement scales in the how can you tell section in the distinction part. So it explains how they determine which, or you've got to explain how you determine which were the weak and which were the strong areas of numeracy for the class, and by interpreting what the levels on the measurement scales mean. Okay, so basically it's about really talking about what the level is, so how high or low that they were on the scale of measurement, which is the range of values on the axis when we're graphing, really. So the scale of measurement ranges between 0 and 35 for the numeracy because there's 35 questions. Okay, in terms of the data that we've got along that scale of measurement, it really falls between, I think, 7 and 27 in my data set. So it's all about that. I think it's intuitive that 7 is quite low in that 35 question part, but 27 is quite high. And we have a real good handle by using the standard deviation about what sort of frequencies of these different ranges would be expected in a normal distribution. Okay, and it's something that how close that you feel that your distribution is to a normal distribution. When we make a histogram, will probably indicate how assertive you are when you describe it and indicate this, but I think at least it gives you a pretty good guide that the expectation would be these 68% and 95% of values falling within certain ranges. Okay, so that would more than adequately cover at a distinction level if you cover those things.